Guys, in this one we're going to be evaluating our trig ratios, specifically sine, cosine, and tangent, and we're going to leave out cosecant, secant, and cotangent because I'm well aware that everybody out there in YouTube knows that you probably just need to reciprocate sine, cosine, and tangent to find those. So, we're going to be doing these specifically for the angles 0 degrees, 30, 45, 60, and 90 degrees. And as far as the 0 and 90 degree cases go, I'm going to go ahead and fill those in for you today. That is, we're going to generate a whole table and talk about some relationships that exist in this table, help you better understand the relationship between the trig ratios of these angles. So, to start with, we say 30 degrees, 45, and 60, primarily because we are very, very well aware of the relationship that exists between the sides of a 30, 60, 90 and a 45, 45, 90. So we'll go ahead and start with our 45, 45, 90 case, which of course is isosceles. But remember, you probably don't know me, sorry. I always look at the short side of the triangle first. So we're going to go ahead and give the short side of a triangle a name. I'm partial to A. We know this is isosceles, so I'll call this A, but in a 45, 45, 90, of course, we have A, and then the short side A times radical 2. In a 30, 60, 90, let's go ahead and sketch this guy. So 30, 60, 90, roughly sketched. Here's our 90, we've got our 60, 60, and our 30, and we say, of course, the short side, again, we'll always look at the short side first. We'll call the short side A, but if you know the short side, the fact of the matter is this: the hypotenuse is twice that length, and the long leg is that short side times radical 3. So this being filled in, we can start investigating these. So let's go ahead and do, say, sine of a 30, sine of a 45, and sine of a 60, starting with sine of a 30 degree angle. So we say, okay, so sine of a 30 degree angle, we know we can sketch our 30, 60, 90 triangle whenever we need to find this out, but we've already got it sketched, so let's take a look. Sine of 30, so here's our 30 degree angle here. We want to go opposite over hypotenuse. We end up with, seems A over 2A, and you might recognize that the A's cancel, and we have a 1 on top, but you get a half. Okay, so talking about our table here, what if we said like sine, cosine of, we'll go with theta, an angle's theta, and tangent of theta, and across the top here, we'll just sketch in our different angles. So this will be a good table. So we've got 0 degrees, 30, and thanks for being patient here. And sine of 30, we can go ahead and fill that one in if you're doing this with me. It's a half. We just found that at 60 degrees and 90 degrees. Okay, so sine of 30 we just determined was a half. Okay, so now moving right along, what if we did say sine of, say, 45 degrees? Okay, 45 degrees. Well, at 45 degree angle, we'll go over to our right triangle here, or excuse me, right triangle, or isosceles triangle, and you can use either 45, but sine of 45 would be A over A radical 2. Okay, so A over A radical 2, this does simplify, so we have A over A radical 2. The A's cancel, and so I have 1 over radical 2. And rationalizing that, that ends up as radical 2 over 2 if you multiply the top and the bottom of this guy by radical 2. Like that. Okay. So we get radical 2 over 2. It's not a good roll so far. And then let's go over to 60 degrees and see what we find out. So sine of, whoops, let's do this color. Sine of 60 degrees. 60 degrees. So our 60 degree angle, which is up here, sine of that would be opposite of that, which is A radical 3. All over the hypotenuse length of 2A. So our A's again cancel, and we get left with radical 3 over 2. So, one thing I want to point out to any viewers out there is the fact that if you're looking at this table, from 30 to 45 to 60, the sine of all of those angles, you'll notice that they all have something in common. They're all over 2. And that technically I could put a radical sign over this 1, and that would be consistent because the square root of 1 is 1. But you'll notice I have radical 1, radical 2, radical 3 on top. Okay, now the interesting thing is, whoops, let me go and put that 2 back over here. As per our last video on cofunctions, we know this. If we say sine and cosine are cofunctions, so if we were to say take the sine of 30 degrees, that would have to be the same thing as the cosine of 60 degrees because they're cofunctions and 30 and 60 are complementary angles. Likewise, the sine of 60 degrees, which is radical 3 over 2, sine of 60 has to be the same thing as cosine of 30 because they are cofunctions of complementary angles. And then 45, well, hey, that's complementary to itself. So the sine of 45 is the same thing as the cosine of 45. So you'll notice that already in this table we've got this relationship here. They're kind of backwards. So 45-degree angle, you should always remember the sine and cosine of a 45 is just radical 2 over 2. But as far as sine of 30, just memorize that one. Just memorize that one. And the reason behind that is, once you know sine of 30, you know cosine of 60. And once you've got those two relationships, and you know that your 45s are both radical 2 over 2, or radical 2 halves, then you know the other ones are radical 3 over 2. So what about these other values I said that I promised you? Sine of 0 degrees is 0. And since 0 is complementary to 90 degrees, and sine is cofunctions with cosine, then the sine of 0 is the same thing as the cosine of 90. And the sine of 90, which is 1, is the same thing as cosine of 0, because they are cofunctions. So, you know, knowing sine even, just sine, gives you cosine. So the other one that we really do need to go in and fill out here is going to be for tangent. Tangent is a little bit different, okay? I will tell you this, tangent of 0 is 0, got the right color here, and tangent of 90 is undefined. Okay. So that being said, let's go ahead and find tangent of 30 degrees. So tangent of 30 degrees, we've got our triangles up here, let's refer to them. So tangent of 30 would be opposite over adjacent, so a over a radical 3. So a over a radical 3, our a's will cancel, we have 1 over radical 3, which when we rationalize the denominator here, we get radical 3 over radical 3. End up with radical 3 over 3. So radical 3 over 3. Tangent of 45 is one of my favorites. Tangent of 45, you'll see in just a second here. Go up to your 45-degree angle. Opposite 45 is A, and adjacent to 45 is A. So you end up with A over A, which is just, yeah baby, 1. And then last but not least, we say tangent of 60 degrees. Okay, so tangent of 60, opposite of 60 is A radical 3, and then adjacent to our 60 is A. So those cancel out, and you're left with radical 3, so radical 3. Okay, so the one thing to keep in mind is when you evaluate for tangent, it's always involved with some sort of radical 3 or 3's in there, and sine and cosine of 30, 45, and 60, they are all consistently over 2. You get this pattern with the radicals here. 1, 2, 3 for sine, so backwards for cosine is 1, 2, 3. We also know the relationship between, say, cofunctions of complementary angles, how those work, okay? So, you know, getting this list down is helpful because then we can start to evaluate some trig functions. So, sorry to block off not a lot of space here, but let's say, you know, somebody says, hey, would you please and thank you then maybe show me that cosine squared of, say, 30 degrees, cosine squared of 30 degrees plus sine squared of 30 degrees, and this we'll learn this semester as a form of the Pythagorean identity, but is equal to 1. Okay, so we can do this. I did want to point this out real quick for those of you new to trig. We put the squared on the trig function between the trig function and the angle itself. We don't put it on the angle, and the reason why is because people might think that we're squaring the 30 degrees, and we're not really doing that. This just means cosine of 30 degrees, whatever that is, square it. So I'm actually going to rewrite this as those squared, and we're going to refer to the table up here, but hey, cosine of 30 degrees, we should know cosine of 30 degrees. It says radical 3 over 2. And then we say sine of 30 degrees. Sine of 30 degrees, of course, is a half. And then we can square both of these. So squaring radical 3 over 2, we get just 3 over 4, which is 2 squared, plus, 1 half squared is a fourth, and I get 1. So, hey, what do you know? 4 fourths does indeed equal 1 any day of the week. So, this is actually valid. Let's see. What if you know, I said, could you evaluate 4 times sine of 45 degrees? Why not sine squared 45? So this isn't brutal here. Just like order of operations, we're going to assess, you know, parentheses, but exponents first in this case. So we say 4, and then the sine of 45, whatever that is, we're going to square it. So sine of 45, looking at the table up there, is radical 2 over 2. That part's over. It's like done. So we can just go ahead and evaluate this now. We got 4 times, well, radical 2 over 2 squared should be just 2 over 4. And beautiful, but our 4's just canceled. We get left with, hey, this is all 2. Okay. So that is a very, very formal explanation, or exploration, excuse me, the trig functions of those very, very special angles.